Yeah, good evening, children. Good evening. Good evening, online students.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. I've shared my screen. It's visible, right?
Yes, ma'am.
And I think last class we completed till here. Correct?
Yes, ma'am.
Yeah? Okay. Fine. So we need to continue from here, right? This is the next one, right? Okay. So see this one. Prove that root 5 is an irrational number. Prove that root 5 is an irrational number and hence show that 2 minus root 5 is also irrational. All right. Do it now. Let me see how you prove that root 5 is irrational. Yes, online students, take down this question. We have already worked the proof for root 5 irrational. Do that once again. You can take the table closer to you, Ritika. Pull the table closer to you. Yeah. Yeah, done, children.
Completed, ma'am.
Very good.
Completed, ma'am.
Yeah, if possible, children, online students can take a picture and share it on WhatsApp with me. Yes, Sashank, I want to see your work. Completed and get it here. Krishmi also. Completed, Rakshita.
1 minute, ma'am. Last sentence. I'll send you the picture.
Very good. Very good. Yes, Krishmi. No, you need to practice. No, why? Next class, I'll again check. You should do it correctly. All right. Please practice. Yes, you. Same thing. You need to practice. See? Girls, Ritika, finished? Not that. That I did not ask you to do. Only the first part? Yeah, this will do it. The mother product of division, you should learn to write like this. 5 is equal to a square by b square. Don't use a slash. Don't use a slash. Okay. Root 5 is not rational. Root 5 is rational. இன்னும் இதெல்லாம் நம்ம own words எழுதிக்கூடாது. அங்க இருக்கிற மாதிரி எழுதினா it will be better. Okay, good. All right, I've received from the online students also. All right. So the next part can show that 2 minus root 5 is also irrational. So how do we do that? Yeah, Raghavi wants to say. Yeah, tell me. Let If possible, right? If possible, let louder. Let 2 minus root 5 be rational. Yeah. Then 2 minus root 5 is equal to a by b, where a and b are co-prime integers. Co-prime integers. Okay, then. Yeah, after this, children.
Ma'am, cross multiplication.
Now cross multiply or transpose? Transpose. Transpose. Okay, so yeah. So it will be minus root 5, or you can take root 5 to the other side. So it will be 2 minus a by b is equal to root 5. Is this correct? We're trying to gather the rationals or the integers on one side. Okay, so 2 minus a by b is equal to root 5. Next what? Common denominator. 2b minus a by b is equal to root 5. Now, are integers. Are integers, correct. So this means rational. But we know that root 5 is irrational. Very good. Very good. Yeah. So, yeah, start writing. Done, children? Done, children? Online students?
Yes, ma'am.
Yeah. Try this one. Oh, it's worked, is it? Okay, fine, fine. I thought I don't have the answer. Okay. All right, children, please see the screen. See the board. So if possible, let root 3 plus root 2 plus root 3 be rational. Then root 2 plus root 3 is equal to a by b, where a and b are co-prime integers, correct? Okay, so now we have, now what you have to do is when, now here you know in this expression that both root 2 and root 3 are irrational. You know that both root 2 and root 3 are irrational. What you have to do here is, you'll have to take one of them to the other side. Transpose any one of the two. See, in this case, you don't have a choice. You have to transpose 2. See here. In this case, you know, where one, you know that 2 is rational and root 5 is irrational. Here you don't have a choice. You have to transpose, you have to have 2 and a by b on one side. Correct? See, when you have to show that 2 minus root 5 is irrational, in this step, you have to transpose. Here you do not have a choice. You have to have 2 and a by b on one side and root 5 on the other side. Correct. But here you have a choice. What is the choice? You can either take you can either transpose root 2 or root 3. So what have I done? I have transposed 3. I've taken 3 root, sorry, I have transposed root 3. I've taken this root 3 to the other side. You can even take root 2 to the other side. Look at this step. So root 2 is equal to a by b. I've transposed this. Here you have a choice. You can transpose root 2 or root 3. I have transposed root 3. You can do root 2 also. Okay, so this is equal to a by b. On transposing root 3, you get root 2 is equal to a by b minus root 3. At this stage, you have to square on both the sides. At this stage, you square on both the sides. So root 2 the whole square is equal to a by b minus root 3 the whole square. Root 2 the whole square is 2. And when you square this, use the identity x minus y the whole square. What is x minus y the whole square? X square plus y square minus 2xy. X minus y the whole square. This is x minus y the whole square. Is x square. Okay, is x square. This one. A by b the whole square, which is a square by b square. X square plus y square. So root 3 the whole square is 3. So plus y square. Minus 2 into a minus 2 into x into y. So minus 2 into x into y, which is 2 root 3a by b. Okay, so that's the next step, squaring on both the sides. All right, now common denominator. B square is the common denominator. In the RHS, B square is the common denominator. So common denominator. So you get a square plus 3b square minus 2 root 3ab. So how do we do this? Common denominator, how does that happen? See here. Yeah, so 2 is equal to b square is a common denominator. So you have b square here. So a square as it is. Here it's 1 by 1. So you need to multiply by b square. So into b square, 3b square. Correct? And then here there is a b. So into b to get b square. So here into b. 2 root 3ab. Now cross multiply. Now you can see earlier we had root 2 and root 3. Now we have only root 3. Now we have only root 3. By squaring on both the sides, first we transpose and then we square on both the sides. On doing this, what happens? We have only one irrational here, root 3. So now you have to gather all the integers on one side and have root 3 on the other side. Okay, so cross multiply. So you get 2b square is equal to a square plus 3b square minus 2 root 3 ab. All right. So now I've just transposed, like I've got this one here. So 2 root 3 ab is equal to a square plus 3b square minus 2b square. So root 3 is equal to, simplify, 3b square and minus 2b square is b square plus b square. So a square plus b square by 2ab, transpose. So you're basically collecting all the integers on one side and having root 3 on the other side. Because you know that a, b and 2 are integers and root 3 is irrational. We know that. We know that root 3 is irrational. Okay, so we have root 3 on one side and we collect a, b and 2 on the other side. So now the same thing. This one is made up of integers. So it's rational. But root 3 is irrational. It's an equality. You cannot have a rational on one side and irrational on the other side. It's an equality, right? Equality means both the sides are equal, meaning both must be rational or both must be irrational. So this is a contradiction because on one side you have a rational, on the other side you have an irrational, and we have an equality sign in the middle, connected by an equality sign. So this is not possible, correct? And this is due to our incorrect assumption that the given expression is rational. Therefore, it is irrational. Got it? Yeah, please write. finished writing, online students?
Just a minute, ma'am.
Okay, okay.
Completed, ma'am.
Yeah, good. So what do we see here? In this expression, we know that both root 2 and root 3 are irrational. And so the sum of two irrationals is always irrational. The sum of two irrationals is always irrational. Except for cases like this, like supposing you have root 5 plus minus root 5. These are two irrationals. These are two irrationals. Root 5 and minus root 5 are irrationals, but their sum is rational. So you consider this case where this is irrational, this is also irrational. So here the sum is irrational. We know that. Because what is root 2? It's a non-terminating, non-repeating decimal. What about root 3? That is also a non-terminating, non-repeating decimal. And then what will you say about the sum of these two? That will be a different non-terminating, non-repeating decimal and hence irrational. Correct? Root 2, non-terminating, non-repeating. Root 3, non-terminating, non-repeating. Their sum will produce a different non-terminating, non-repeating decimal. And so root 2 plus root 3 is irrational. Here, in this case, the sum of two irrationals is also irrational. We know that, but how do you prove? So I'm just repeating the proof. So assume this to be rational and equate it to A by B. Now, since you know that both root 2 and root 3 are irrational, you need to take one of it to the other side. Any one of it to the other side, either root 2 or root 3. After that, square on both the sides. Okay, square on both the sides. So here you'll have to use identity x minus y the whole square and square it. So this is what you get. At this point, common denominator. And this is what you get. After that, Raghavi, are you looking at the board? Cross multiply. Cross multiply. And now when you observe, you see that all are integers except root 3, which is irrational. All are integers, meaning all are rational except root 3. So now you know what to do ahead. You want to have root 3 on one side and the remaining, all the integers on the other side. So do the needful for that. So there is no particular procedure that you'll have to do this. The idea is have root 3 on one side and collect all the integers or the rationals on the other side. So that's what is happening. So in doing so, we find that these two are like terms, so we simplify them. These are like terms, so we simplify them and then transpose, and this is what we have. So at this point, what will you say? This is rational because A, B, and 2 are integers. But this means, see, so this presentation can be different. So this implies root 3 is also rational, correct? Because if this is rational, it implies root 3 is also rational. But this is a contradiction because we know by the theorem that root 3 is irrational. We know by the theorem, if this is rational, it means this is also rational. But we know by the theorem that root 3 is irrational. So it's a contradiction. And that's due to the incorrect assumption. So it is irrational. So it is not rational, it is irrational. Here, what we had to do? Here, you have to transpose 2. Yeah, you have to transpose 2. Here, you don't have to square on both the sides. Squaring is only when in the expression, both the terms are irrational. Only then you have to square. In the expression, when both are irrational, you'll have to transpose one to the other side and square on both the sides. If one is, you know that 2 is rational, only root 5 is irrational. So here what you should do, take 2 to the other side. That's all. No squaring here. Yeah. Do this one. You can help yourself. Children, go through the slide, understand, and then complete this. We've already finished this, is it? Oh, many that day when you got. Oh, yeah, right. Okay. Yeah, instead of just waiting for the others to complete now, Sashank has to complete. If you feel it will become a double entry, don't just go through that. So. Yeah.
Completed, ma'am.
Yeah. Done all of you?
No, ma'am.
Okay. Done? Yeah. Rajat? Let me know once you finish writing.
Done, ma'am.
Okay. Finish writing this? Yeah, I think yes. No? Did I share the notes with you? No, right? I'll share it with you. Don't worry. No, some of us do not have all this, so let me do one thing. Okay, I'll send these images on WhatsApp, Sashank. You can complete them, all right? Yeah, I think all the others would have completed. When did we write all this? Last Saturday, is it? Sure, right. Okay, I'll resend everything. Don't write now because we've already finished this. I'll share this with you on WhatsApp. You can complete it. Okay, now look at this one. If A is rational and and root B is irrational, then prove that A plus root B is irrational. If A is rational and root B is irrational, prove that A plus root B is irrational. Yeah, go through. I'll ask you what you understood. Or if you go through the slide, one of you or a few of you will explain this to me. Okay, so in grade 9, we have understood how rationals and irrationals behave when we use them with different mathematical operations. Now, whatever mathematical operation you perform with the rationals, when you have two rationals, whatever mathematical operation you perform with two rationals, the result is always rational. Now, what do we mean by that? Now, 4 by 5 is rational. 3 by 2, rational. Integer by integer, rational number. Integer by integer, it's a rational number. 4 by 5 is rational. 3 by 2 is also rational. Now, the sum of these two rationals will produce another rational number, a different rational number. Will this be irrational? Will the sum of two rationals tell me two rationals whose sum is irrational? Tell me two rational numbers whose sum is irrational. No, because when you consider two fractions or two rational numbers, their sum is always rational. Similarly, the difference of any two rational numbers, 4 by 5 is rational, 1 by 7 is rational. The difference of these two rationals is also a rational number. You cannot get an irrational answer for this. The product of two rationals, I'm just taking 4 by 5 repeatedly, so anything, the product of two rationals is also rational. The quotient of two rationals, except division by 0, because we know division by 0 is not defined. 0 is an integer, 0 is rational, 0 is an integer, 0 is a rational number. But we know that division by 0 is not defined. So like 5 by 0 is not defined. Other than division by 0, the division of any two rationals will always produce a rational number. Division by 0 is not defined. 0 is an integer. 0 is a rational number. Division by 0 is not defined. Division by 0 will not give you a rational number. That's what I'm trying to say. Division by 0 will not give you a rational number, except for that. That is the only exception. Apart from that, when you consider two rationals and find their quotient, that will be rational, which means the sum, when you consider any two rational number, their sum, difference, product, as well as quotient is always rational. That's what it. Okay, you agree that it produces a rational number. A P by Q form can never have a non-terminating, non-repeating decimal. If it's a P by Q form, if the answer is a P by Q, it can never have a non-terminating, non-repeating decimal. Only if the answer is like root 2, root 3, root 5, or 1 by root 2, 3 by root 5, only such expressions can have a non-terminating, non-repeating decimal expansion. Otherwise, integer by integer will not have a non-terminating, non-repeating decimal expansion. Integer by integer will not have a non-terminating, non-repeating decimal expansion, because we know that when we divide a number by another, the division will either come to an end with a zero remainder, in which case the quotient is terminating, or the division goes on and on. When you divide two numbers, only these two cases are possible. Either the division comes to an end with a zero remainder, in which case you have a terminating decimal as a quotient, or the division goes on and on, in which case the quotient is a non-terminating but repeating decimal. On division, you cannot get a non-terminating, non-repeating decimal. Yeah, so not possible. So this is what it is. So the sum, when you consider two rational numbers, their sum, difference, product, quotient is always rational. Okay. Now what is it? A is rational is given. A is rational is given. Root B is irrational is also given. Root B is irrational is given. Now you will have to prove that A plus root B is irrational. All right. Okay. Now see here. We'll assume that this is rational. We have to prove it is irrational. We have to prove it is irrational. We'll assume that it is rational. Okay. Now this is rational. This is rational. We know that the difference of a rational or the difference of two rationals is always rational. We know that the difference of two rationals is always rational. Now this is rational. We are assuming that this is rational. Minus, we know that A is rational. So minus the rational A. A plus root B, we have to prove is irrational. We are assuming it to be rational. Okay, if possible, let it be rational. Now we are using the rule that the difference of two rationals is always irrational. The difference of two rationals is always rational. Now, if this is rational, if this is rational, we know, then their difference should be rational, right? But what will you get? A and minus A will get cancelled and you will get root B. You should get a rational result. You must get a rational result, but we know that root B is irrational. So you're getting an irrational result. How can you get an irrational result? The difference of two rationals must be rational. But here, when you assume that A plus root B is rational, minus A, which is rational, we know the difference should be rational. But what is the difference we are getting? We are getting root B. And root B is given in the question or the statement that it is irrational. You're getting an irrational value. No, that's not possible. The difference of two rationals cannot be irrational. This is a contradiction. So our assumption is wrong. We are dealing only with real numbers. If there's a contradiction, that means our assumption is wrong. So the opposite is right. So what was our assumption? That it is rational. That's wrong. So it is irrational. This is another way of proving. You can do that here also. That's applicable here. That's applicable here. I'll come back to this, okay? Let me just finish. I'll come back here. So let me do it again. This is given to be rational. This is given to be rational. And this is given to be irrational. Now we have to prove that this is irrational. But we are going to assume the opposite. If possible, because we have to prove it is irrational. That means it is irrational. We have to prove that. We are assuming the opposite. If possible, let this be rational. If possible, let this be rational. Now we are going to use the rule that the difference of two rationals is always rational. The difference of two rationals is always rational. Now we have assumed this one to be rational. Okay, let's write that. This is rational by assumption. Difference means minus. Now we are considering another rational number, A. That is rational because it's given. Now what should be the difference of these two? It can be anything which is rational. But what will you get? Minus A plus A cancels. And you get root B. Now what is root B? You should get a rational result. But it is irrational because it's given it's irrational. You cannot get an irrational answer. So this situation is incorrect. This situation should not happen. Why has it happened? Because our assumption is incorrect. Yes. So it is irrational. So our assumption is wrong, which means A plus root B is irrational. Now this rational irrational has become a kind of a tongue twister for me. I mean, yeah. Now go through the slide. Need not write. I think you've already written it. Online students, I think we have already written this. Please flip the pages and flip back and see. We have already completed this. All online students, we have already written this. You don't have to write. Now just go through the slide and understand. So if possible, let this be rational. We know that the difference of two rationals is always rational. So this is rational minus A. You get root B. So that means this is rational. That means this root B is rational. No, but this contradicts the given fact. What is the given fact? That root B is irrational. Correct? This is due to our incorrect assumption. Therefore, this is irrational. Is that fine, all of you? Yeah. Go through this. I've done it in two ways, I think. I've done it in two ways. Please go through this. So what's the first one like? If possible, so you need to prove that A root B is irrational. You need to prove that A root B is irrational. That is the product of a rational and irrational is irrational. A is rational. Root B is irrational. We need to prove that the product of a rational and irrational is irrational. See, it's given here. A is a non-zero rational, meaning it's not zero. A is not zero. A is not zero. It's a rational number. Root B is irrational. You need to prove that their product, that is the product of a rational and irrational. A is rational, root B is irrational. We need to prove that the product is irrational. Like for example, 3 into root 5. 3 is rational. Root 5 is irrational. The product is 3 root 5, which is irrational again. Okay, so the two ways are, so this is if possible, let it be rational. And if it is rational, then it's in the form P by Q, because we already have A and B here. So I have not called it A by B again. You can use P by Q or X by Y. So A root B is equal to P by Q. Correct? A root B is equal to P by Q. Now there's only one irrational, right? Root B alone is irrational. Root B alone is irrational. A is rational. Transpose. Bring it down to the other side. So root B is equal to P by AQ. Now what happens? All these are integers. But this one, all these are integers, so this is rational. But this is irrational. That's all it is. So just bring this. Just transpose this. So root B is irrational. But since P, A, and Q are integers and they are rational, it's a contradiction because this is irrational and this is rational. So contradiction, incorrect assumption. Okay. The other one here is, what you see here is using the rule that the product of two rationals is always rational. The product of two rationals is always rational. We just saw that, no? We just saw that. The product of two rationals is always rational. Okay. So here A root B, supposing you assume it to be rational, you know that A is rational, correct? You know that A is rational. A is not 0. A is not 0. A is rational. So that means, say like A is something like 5. So 5 is rational, which means 1 by 5 is also rational. Its reciprocal is also rational. If A is rational, A is not 0. Because if it's 0, then 1 by 0 is not defined. If A is 0, then its reciprocal, 1 by 0, is not defined. That's why it's given A is a non-zero rational. So A is not 0. So A is 5. What is 1 by A? 1 by 5. Okay. So the product of two rationals is always rational. So we'll take the reciprocal of A. The reciprocal of A is 1 by A. So this one we are assuming it to be rational. This one is rational. This we are assuming it to be rational. This one is rational. The product should be rational. The product should be rational. But what happens? We are getting root B. And root B is irrational is given to us. Root B is irrational. But the product should be rational, right? Which means the product, this one is rational. That means the product, this one is rational. Because the product of two rationals is always rational. That means this product, whatever you get, is rational. But this is a contradiction because root B is irrational. We know that root B is irrational. So that's a contradiction. That's because of our incorrect assumption. So A root B is irrational. Here we're using the fact that the product of two rationals is always rational. We're using that rule. The product of two rationals is always rational. We know that A is rational. That means 1 by A is also rational. We are supposed to prove that this is irrational. We are assuming the opposite, that if possible, let this be rational. Okay, so we are assuming this to be rational and we are really multiplying this by a rational. We are multiplying that by a rational. This one we are assuming it to be a rational. So supposing this is rational and you multiply by 1 by A, which is rational, the product should be rational. But what happens? A gets cancelled. You get root B. That is supposed to be rational. But is it that root B is supposed to be rational? Because the rule is the product of two rationals is rational. So root B is supposed to be rational. But no, it's given that it is irrational. It's given that it's irrational. So it's a contradiction. And that's because of the incorrect assumption. And hence A root B is irrational. All right. So this is using that A by B form, P by Q form, then transposing the, meaning having all integers on one side and the that root factor, on the other side. That is this method. That is this method. And both are fine. Both are two different methods. Both are fine. So I'll send all these images on WhatsApp today. You people check. If you've already written, you don't have to do a double entry. If I think this one I've included now, I think this method I've included. So you can check that at home. You can check that at home. And if this needs to be included, you can add it. Okay. So this now you can understand. I'll send this also. I'll not bug you because it's the same thing, children. See here. You understand, no? It's the same thing again. Prove that 1 by root 2 is rational. You can help yourself. So here I've used that fact. Maybe sometimes what I do know when I make the presentation, I'll change the method sometimes. So you please see if this is the method you have used to work in the classwork the other day. If it's a different method, you can work it. So you can always work it for practice. Yeah. So here, what I see is I've used that method here. That is the sum of two rationals is rational, or the product of two rationals is rational. The difference of two rationals is rational. That's what I've used here. No, 1 minute. We'll just do one of it. Okay, so that 1 minute. Let's just take up this 5 minus 2 root 3. 5 minus 2 root 3. So if possible, let this be rational. Now, what should you do to remove that 5? You should remove. You should no transposing. Subtract 5. Okay, the rule is the difference of two rationals. The difference of two rationals is always rational. Online students. Please listen carefully. See here. 5 minus 2 root 3. This we have to prove it is irrational. We'll assume the opposite. If possible, let it be rational. Now we're going to use the fact that the difference of two rationals is always rational. Okay. So you want to remove this 5 from here. So what should you do? You must subtract 5, right? Yes or no? So what will happen? 5 minus 5. And you're left with minus 2 root 3. Now you still can't comment. Now we'll continue with this minus 2 root 3. Minus 2 root 3. Now we are going to say that the product of, now see here, the difference of two rationals is rational. So we assume that this is rational and we are proceeding. The difference of two rationals is rational. This is rational now. According to the rule, this is rational. Now we are proceeding with that. This is rational. So the product of this rational and another rational. Correct. The product, now, minus 1 by 2 is rational. That you don't have to prove. Integer by integer, it is a rational number. Minus 1 by 2 is rational. Now this one is rational because the rule is the difference of two rationals is rational. This is rational. Proceed with that. Rational into rational. 2 gets cancelled. Plus root 3. Now, this is what rational? Because what's the rule? The product of two rationals is rational. So this is rational. No, but we know root 3 is irrational. We know root 3 is irrational. We have proved. It's like a theorem now for us. Root 3 is irrational, we know, but we are getting rational here. Contradiction. Incorrect assumption. That's all. All right. Okay, let's do the same for. So here you have 2 steps. See, here you have 2 steps. One rule is difference of two rationals is rational. The other rule is the product of two rationals is rational. So we need to use 2 rules here. Because first you need to get rid of 5 and then you need to get rid of this 2. So 2 rules we used. Difference and then product. Okay, now what about this 3 plus 5 root 2? Online. Who wants to try this? Online students? Danya? Yeah, okay, fine, you can try. Danya? Danya's not there. Oh. Arjun?
Ma'am, can I try?
Okay, Rakshita. Yes, Rakshita.
Yes, ma'am. So first, we will subtract -3.
Subtract 3.
Yes, ma'am.
Not subtract -3, subtract 3.
Yes, ma'am.
Very good. What's the rule? The
Difference of rationals is always rational.
very good. The difference of two rationals is always rational. Okay. Then what will happen?
5 root 3. We'll get the answer as 5 root 3.
Very 5 root 2.
Yes, ma'am. Sorry. 5 root.
Yeah. Now, by the fact this is rational. By the
Yes,
fact
ma'am.
this is rational because the fact says that the difference of two rationals is rational. So this is rational. Now we have
Yes,
5
ma'am.
root 2. Next what?
Ma'am, next we'll use the rule that rationals multiplied with rational will always give rational.
Very good. Very good. Yes. So you will
So
multiply
we
by
will 1 by 5.
very good. 5 cancels.
Cancel. Yes,
Now
ma'am.
the product should be rational. So this is rational.
Yes,
but-
ma'am.
Yeah, but
We know that root 2 is irrational, so this contradicts.
very good. There's a contradiction. That means that's because our assumption is wrong. So it is irrational.
Yes, ma'am.
Very good.
Yes, ma'am.
Very good. What about 3 root 7? Who wants to try here?
Can I try?
Yes, sure. Who's that?
Arjun, ma'am.
Arjun. Yes, Arjun. Arjun,
Ma'am,
see from next. Are you in town, Arjun?
yes, ma'am.
Then wife online classes. Okay, fine. From the next class onwards, please come to the center. All right?
Ma'am, yes, ma'am.
Yeah.
Ma'am, let 3 root 7 is rational, ma'am.
Okay.
3 root 7 equals a by b.
Okay.
We get root 7 equals a by 3b.
Okay.
So a, 3 and b are integers, so it is rational number.
Very good.
While root 7 is
Irrational.
irrational, ma'am.
It's a
This
contradiction.
contradicts that root 7 is irrational.
Yeah. Very good. What's the other method, Arjun? Other method, Arjun, using the fact based on rational numbers. I'm saying this fact based on rational numbers. Yes, class here. Yes, Sashank. Okay, that method he already told us. That's what Arjun said. One by? Yeah. Very good. So what's the fact you've used here? The product of? Yeah. So if you assume that 3 root 7 is rational, the product of 3 root 7 and 1 by root 3, 1 by 3, sorry, this is rational. We are assuming this to be rational and 1 by 3 is rational. The product of two rationals will produce a rational number. So that means it's producing the result root 7, which is rational, which is supposed to be rational, but it's irrational. That's a contradiction. And that's because of our incorrect assumption. Okay, so I'll share this one also, children. Okay. Oh, I've written it in words as a statement, is it? Okay. Okay. That's all, children. This is so. I'll share these slides. You please check, and whatever you need to complete, you can do. Yeah. This also, I'll share the notes, Sashank. The others have completed this. So all this you've written, children, online students, don't write anything. You already have these notes in your book. Please listen carefully. That's all. Yeah. So now there's something called Euclid's division lemma. Lemma means a rule. It's a very old term, you know. We don't use this term now. So lemma basically means a rule. Like you say algorithm, division algorithm. Division algorithm is dividend is equal to divisor into quotient plus remainder. So that's a division algorithm. So like that division lemma, meaning it's a rule. Euclid's division lemma. So this basically states that when you have two numbers, when you have two integers, two positive integers a and b, positive integers because that's what you divide, no? See, if you want to divide, if you want to find this quotient minus 35 by 7, you are not going to divide like this minus 35 by 7. No, you're going to divide 35 by 7 and then you will fix the minus sign or whatever sign accordingly. So if we normally divide two positive integers, the dividend is positive, the divisor is also positive. See, maybe it's okay, you have to divide minus 35 by minus 7. So you're not going to write minus 35 divided by minus 7 like this and say the tables of minus 7. No, we'll cancel out the minus signs and then you'll divide 35 by 7. So you are always going to take a positive dividend and a positive divisor. So that's how the statement begins. If you have two positive integers a and b, why we say positive integers? Because that's how we divide. The dividend is positive, the divisor is also positive. Even if you have to find minus 35 by 7, you are not going to take minus 35 as the dividend. You're going to take only 35 as the dividend. Okay. So Euclid's division lemma states that given, don't write anything, children. Why are you getting ready for something? No, don't write anything. Yeah. No, don't write anything. I'll tell you. Euclid's division lemma states that given two positive integers a and b, there exists unique integers q and r. Because yeah, when you perform the long division, you will get two new numbers called the quotient and remainder. So if you have two positive integers a and b, then there exists unique integers q and r. Why unique integers? Because when you divide 35 by 7, whoever divides this, all of us will get 5 as the quotient and 0 as the remainder. So there exists unique integers. Unique meaning one answer only. Unique meaning only one answer. There exists unique integers q and r satisfying the relation. What relation? Division algorithm. A is equal to bq plus r. Why A is equal to bq plus r? Because A is the dividend, A is the dividend, B is the divisor, Q is the quotient, and R is the remainder. A is equal to BQ plus R is basically dividend is equal to divisor into quotient plus the remainder. Okay, so where A is the dividend, B is the divisor, Q is the quotient, R is the remainder. So Euclid's division lemma states that if you're given two positive integers A and B, if you're given two positive integers A and B, there exists unique integers Q and R satisfying the relation A is equal to BQ plus R, where what is the rule? The rule is regarding the remainder. Okay, the remainder can be 0 or anything more than 0, but less than the divisor. The remainder can be 0. The remainder can be anything more than 0, but the remainder should be less than the divisor, not even equal to the divisor. It cannot be equal to the divisor. When you divide by 7, you cannot get 7 as a remainder. Okay, so what are the conditions for the remainder? The remainder can be 0, or the remainder will be anything more than 0, but the remainder will be the remainder will be less than b. The remainder will be less than b. Okay, so that means see here, remainder can be equal to 0 or greater than 0, right? So greater than or equal to 0. Is this correct? But the remainder should be less than b. Now, online students, are you all focusing? Are you listening carefully?
Yes, ma'am. Yes, ma'am.
Yeah. So the remainder can be equal to 0 or the remainder can be greater than 0. Putting these two together, remainder greater than or equal to 0. But the remainder should be less than the divisor, less than b. Now we'll combine all this and write a complex inequality. This is an inequality. Inequality meaning 3 is less than 4 is an inequality. Because when you use the greater than or the less than symbol, when you use the less than or greater than symbol, it's an inequality. When you use the equal to sign, it's an equality. Correct? Okay. So now this is an inequation. Now listen to this. If 3 is less than 4, that means 4 is greater than 3, right? When you change their places, if A is equal to B, B is equal to A, you will not change the equality. Equality remains an equality. But 10 is greater than 9. If you write 9 here and 10 here, you will not write greater than. You will write 9 as 9. You will change the inequality. You will change the inequality. When you change the places, you will change the inequality. Now listen to this carefully. Remainder equal to 0 or greater than 0, greater than or equal to 0. Now if I write 0 here and R here, you must write less than or equal to. Okay. And then what's the other thing? The remainder should be less than the divisor. So remainder is less than the divisor. See here. You have both here. You have both the inequalities here. I've combined both now. What was the first one? Remainder greater than or equal to 0, but the remainder should be less than the divisor b. Now we are combining both. This can also be written as 0 less than or equal to r. And this one is less than b. Put these two together. So I'm writing this one. See, I'm writing this 0 less than or equal to r. And I'm writing this. Why will I write r again? R is here already, less than b. So this is the combined inequality or the complex inequality. Is this understood? So this basically means that the remainder can be 0 or anything more than 0, but less than the divisor. All right. So if you're dividing by 5, the remainder can be 0 or 1, 2, 3, 4. That's all. All right. Now write this, children. Now write down this. The heading is Euclid's division lemma. Done? Good.
Completed, ma'am.
Okay. Okay, so now we are going to start with this. Show that every positive even integer, okay, is of the form 2q, or sorry, show that every even positive integer is of the form 2q and every odd positive integer is of the form 2q plus 1 for some integer q. So what does it mean? Now, is this even or odd? So this is 2 into 2q, where q is 49. 98 is even. Why? Because you can write it in the form 2 into 49, which is 2q, where q is 49. Q is odd. We are talking about the number 98. We are talking about the number 98. Now, how do you say that 98 is even? Because you can write it in the form 2 into something, 2 into anything, 2 into 49 here, which is in the form 2q, where q is 49. Correct? So we all know that every positive, you can just leave that word. Just leave that word positive. Every even integer, it is positive. Let me not keep saying that, and like it becomes too big. Positive even integer. Okay, so positive always. Okay, so every even integer. Okay, so basically even numbers. So even numbers can be written in the form 2q. Yes, right. Even numbers can be written in the form 2q, 2 into something. Okay, and every odd number, look at the number 15. You can write it as 2 into 7 plus 1. 2q plus 1, where q is 7. Not convincing? 45 is 2 into 22 plus 1. What is 2 into 22? 2q plus 1. Because it's odd, it is in the form 2q plus 1. If it was even, then it will be in the form 2 into 22. 2q. It's in the form 2q where q is 22. That's what you have to prove. Show that every even integer is of the form 2q. Yeah, correct. Even means 2 into something. And every odd positive integer, that is odd number, is of the form 2 into something plus 1. Or some integer q. Q can be any integer. Like here q is integer 22. Here also Q is 22. Like if you take a different number like 50, 2 into 25, where Q is 25, where Q is any integer. All right. Okay. So again, Sashank, the rest of the class have the notes. I'll share it with you. You will have to complete your classwork. Okay. So now here you know that the divisor is 2 because when it is 2q plus 1, it's in the form bq, like A is equal to bq plus r, right? A is equal to bq plus r. How do I tell you? Like, okay, we were talking about 45. 45 is equal to 2 into 22 plus 1. So this B is 2, right? B is 2. So let A be, now A can be anything. A can be 45, 50, 100, 200, anything. So let A be any positive integer and B be equal to 2. Let A be any positive integer. So like say 114 is equal to 2 into 57. So you can see that A is anything is equal to BQ plus R, where R is 0. R is 0. So you can see that B is 2. But A is anything. A is anything. That's what it is. So let A be any positive integer. It need not be even or it can be anything. Let A be any positive integer and the divisor B be equal to 2. The divisor B be equal to 2. Is that understood? A can be any positive integer, but the divisor should be 2. Okay, then by Euclid's division lemma, EDL meaning Euclid's division lemma. That is a division algorithm. What does it state? That when you have two numbers, here you have the two numbers, A, which is a dividend, and 2 is the divisor. Here you have two numbers. A is the dividend, 2 is the divisor. B2, 2 is the divisor. So what does the lemma state? That when you have these two numbers, you'll have two other numbers, Q and R, satisfying the relation A is equal to BQ plus R, and that condition for the remainder. That's what it is. Then by Euclid's division lemma, we have A is equal to BQ. This is the standard one. This is the standard one. A is equal to BQ plus R. This you understand. This is EDL. Now, in this situation, what is B? B is 2. B is 2. B is 2. So everywhere for B, you replace 2. Wherever there is B, replace 2. Now, everywhere there is B, this is B, 2. This is B, this is 2. Now, what is the meaning of this one? 0 is less than or equal to R is less than 2. That means the remainder can be 0. Anything more than 0, that is 1, but less than 2. So the remainders are only 0 and 1. Remainder cannot be 2 because the divisor is 2. Okay, so that means the remainders are, so next step, write this as it is. This one means the remainder can be 0 or 1. Okay, so now take up the remainders one by one. When the remainder is 0, when the remainder is 0, what is A? A is equal to 2Q plus 0. A is equal to 2Q plus 0. That means A is equal to 2Q. When the remainder is 0, A is equal to 2Q plus 0. That means A is 2Q. So when this all of us know. When you can write something as 2 into something, it is even. It's a known fact that when you can write something in the form 2 into something, it is even. So clearly A is divisible by 2. Why do we say clearly A is divisible by 2? Because it is 2 into something. And there is 2 factor. That means it's divisible by 2. You can see the factor 2. That means 2Q is divisible by 2. Okay. So clearly A is divisible by 2. Therefore, 2Q represents an even integer. Because you can see 2Q means you can see the factor 2 here. 2Q means you can see the factor 2 here. That means it's divisible by 2. If it's divisible by 2, it is even. So clearly A is divisible by 2. Therefore, 2Q represents an even integer. Now, we know that integers can be only even or odd. Integers are either even or odd. Now remember that 0 is even. In cases where we need to assume 0 is even, because it can be written as 2 into 0, 2 into something. So 2 into 0 is 0. So in a broad sense, 0 is even. In a broad sense, 0 is even. Okay, so 2q represents an even integer because you can see the factor 2 here. So it's divisible by 2. And if it's divisible by 2, it is even. Now integers are either even or odd. If either integers are even or they're odd. Now if 2q is even, what is the other thing that's happening? 2q plus 1. Then that has to be odd. Because integers can take only two forms. Either they're even or odd. If 2q is even, the other one, 2q plus 1 has to be odd. Because integers are either even or odd. Right? So 2q is even. Now take the other remainder. Remainder is 1. The other remainder is 1. So that means a is equal to 2q plus 1. A is equal to 2q plus 1. So 2q plus 1 itself means 1 is a remainder, right? 2q plus a remainder is there. 2q is even and there is one remainder. So that means it has to be odd because even and odd numbers are consecutive. If 2q is even, 2q plus 1 has to be odd because after an even number is an odd number. Okay, so since integers are either even or odd, when r is equal to 1, a is equal to 2q plus 1. Substitute that. When r is 1, a is equal to 2q plus 1. So therefore 2q plus 1 represents an odd integer. Because 2q, because this one is even, the next one, when you add 1 to anything, it becomes, if 2q is even, when you add 1 to this even number, the next one is an odd number. When you add 1, this is even. When you add 1 to this, it's a next number, the consecutive number. It has to be odd. So 2q plus 1 represents an odd integer. All right. So let's do this again. Tell me. Online students, how do we do this? Let A be, tell me, don't see your book. Let A be any, I'll just start for you. Let A be any positive integer and B be equal to 2. Then what? Yes, online students.
Ma'am, A equal to BQ plus R.
Then by Euclid's division lemma, A is equal to BQ plus R.
BQ plus
What's the condition for R?
R is less than B1.
Correct?
Yes, ma'am.
Next step. Next step. Yes, Prajit. What happened?
A is equals to
First, the
Q.
general rule. First, the general. A is equal to BQ plus R. This is the general thing. Now you should use 2. Now you should use 2. Yes, Prajit. A is equal to
2Q.
2Q. For B, you should use 2. 2Q plus R.
R.
Here also.
Ma'am, instead of B, you should put 2.
Very good. Very good. Next. This will come as it is.
Yes,
Because
ma'am.
you cannot do anything with this. What will
Yes,
you do with A is equal to 2Q plus R? Here, what will you do, Prajit?
Since it is less than 0 and greater than 2, less than 2 or equal or greater than 0, R can be 0 and 1.
Yeah. Now take the cases. When R is equal to 0, what do you get? A is equal to
2Q plus 0.
2Q plus 0. That means A is equal to 2Q. A is equal to 2Q. Now, why do you say that 2Q is even? Because you can see the factor 2. 2Q, you can see the factor 2. That means it's divisible by 2. Correct? So 2Q is clearly divisible by 2 and it's even. Then, Prajit, so this is even.
Yes, ma'am.
When R is 1,
2Q plus 1.
2Q plus 1, because when R is 1, it becomes 2Q plus 1. What is 2Q plus 1? Even number plus 1.
Yes,
2Q is even. And what is 2Q plus 1? Even number plus 1.
odd.
Even number plus 1 is odd.
Odd.
Because even odd, even odd, even odd. That's how numbers behave, right? So if 2q is even, 2q plus 1 has to be odd. Therefore, this is odd. All right. So any expression of the form 2q is even, any expression of the form 2q plus 1 is odd. That's what it is here. This is okay. I haven't prepared the answer for this. We'll do this in the next class. I won't. Yeah. Now this one. See this. Show that any positive even integer. So basically even is of the form 4q or 4q plus 2. Okay, so they're saying even means it should be in the form 4q or 4q plus 2. Let's check that. Let's take an even number 2. 2 is even, right? 2 is even. 4 into half. Integer only you should think. Okay, so 2 is equal to 4 into 0 plus 2, where it is 4q plus 2. 4q plus 2. So it's in the form 4q plus 2. Now take 10. Take 10. What is 10? 4 into 2, 8 plus 2, 10. Take 11. No, we are taking only even now. 11 will take, that will come in 4q and 4q. That will come in 4q plus 1 and 4q plus 3. Now we are taking even. Even will be either 4q or 4q plus 2. Odd will be in the form 4q plus 1 or 4q plus 3. Let's try the numbers first. So, okay, 11 means it will come here. It's odd. No, 11 is odd. So it will come here. 4 into 2 plus 3. 4 into q, that is q is 2. 4q plus 3. Yeah, 4q plus 3. It's odd. See here, it's odd. Tell me, you tell me a number. Yeah, 25. It's odd. So I should place it here. 25 is odd because odd means it will be of the form 4q plus 1 or 4q plus 3. So 25 is equal to 4 into 6 plus 1. See, it's in the form 4q plus 1. Take an even number. 80 is equal to 4 into 20. 4 into 20. 4q. 4q. I'm supposing 81. Or okay, 81 will not come here. 82. Even. 82 is even. So 4 into 20 plus 2. So if the expression of the form 4q plus 2 represents even integers. Expressions of the form 4q plus 1, 4q plus 3 represent odd integers. All right. So if you see, if it's given that if for the expression 4q plus 3 is given, immediately you understand it is odd. If the expression 4q plus 1 is given, it's odd. 4q even. 4q plus 2 even. 4q even. 4q plus 2 even. 4q plus 1 odd. 4q plus 3 odd. Now we understand this numerically, but this is what you'll have to prove. Now when it is 4, that means b is equal to 4. You should take b as 4. Because you want to get 4q plus 1, 4q plus 2, 4q plus 3, bq plus r, bq plus r. So b is 4. You want to get 4q plus 1, 4q plus 2, and 4q plus 3. So bq, b is 4, b is 4, b is 4, b is 4. Yes or no? Yeah. So it's similar, children. So I think you can help yourself see it's similar. Now do all this. It can be 0, It can be, the remainders can be 0, 1, 2, or 3. When it is 0, why you have written this? Please look at the board. When R is 0, so this is 0. When R is 0, this is 0. So you get A is equal to 4Q. So, but we know only 2Q is even and 2Q plus 1 is odd. So write it in the form 2 into something. So when R is, we are taking the remainders one by one. When R is 0, A is equal to 4Q plus 0, which means 4Q. That is nothing but 2 into 2Q. So 2 into something is even. We know that that's like a theorem now. 2 into something is even. Okay, so 2 into 2Q. So it's even. That means 4Q is even. Okay. Then remainder 1. When R is 1, A is equal to 4Q plus 1. A is equal to 4Q plus 1. So A is equal to, what is 4Q plus 1? A is equal to 4Q plus 1. That means A is equal to 2 into 2Q plus 1. So like 2 into something plus 1. We know it is odd. See here, 2 into something plus 1, 2Q plus 1. 2 into something plus 1 is always odd. 2 into something is even. 2 into something plus 1 is odd. Because if this is even, when you add 1 to that, it becomes odd. So here, when R is 1, A is equal to 4Q plus 1. And A is equal to 2 into 2Q plus 1. 2 into something is even. This is even. Because it's 2 into something. It's even. Plus 1, it's odd. So 4Q plus 1 is odd. 4Q plus 2. See here. A is equal to 4Q plus 2. When you take R as 2, when you take R as 2, A is equal to 4Q plus 2. So that is equal to 2 into 2Q plus 1. See, basically 2 into something. 2 into something is even. 2 into it can be a big expression also. It can be 2 into A plus B plus C plus D plus E also. Even because it's 2 into something. Okay. So since this can be written as 2 into 2Q plus 1, it's basically 2 into something. Even. Then the next one, when R is 3. When R is 3, A is equal to 4Q plus 3. Now listen to this. So A is equal to 4Q plus 2 plus 1. 3 is 2 plus 1. 3 is 2 plus 1. So A is equal to 2 into 2Q plus 1 plus 1. Here 2 is common. 2 is common. So 2 into 2Q plus 1 outside. So this is 2 into 2Q. This is like 2 into something, even, plus 1 odd. I'll do it here. When it is A is equal to 4Q plus 3. You must write it as A is equal to 4Q plus 2 plus 1. Here 2 is common. So A is equal to 2 into 2Q plus 1 plus 1. Now this 2 into something is even. This is even. Plus 1 is odd. Therefore, this is odd. Therefore, this is odd. Right? So that's what is here. All right. So in the same ways, children, you can understand this. It's the same thing. So please try to understand 3 and 4 by yourself. If you have any doubts, you can ask me in the next class. 3 and 4 similar. Please go through at home. So here I've grouped. Understand this table now. Understand this table. Expressions that represent even positive integers, expressions that represent odd positive integers, expressions that represent integers. You can't say whether it is even or odd. Okay. Now, when an expression is of the form 2Q, it is even. 2Q plus 1, it is odd because 2Q plus 1, even number plus 1, it is odd. 4Q, it is even. 4Q plus 2, we have proved, no? We just proved. 4q, 4q plus 2, 6q, 6q plus 2, 6q plus 4, 8q, 8q plus 2, 8q plus 4, 8q plus 6. All these are even. Always. You give whatever value for q. Now, supposing you take q as 3, 8 into 3 plus 6, 24 plus 6, 30. Now, for 8q plus 6, you give, say, 2. 8 into 2, 16 plus 6, 22, even. These expressions, you give any value for q and check. You give any value for q and check. These will always produce an even number as a result. Now, these will always give you an odd number. You take any value for q. Now, supposing you take 8q plus 7. 8q plus 7. Now, we'll take q as 1. We'll take q as 1. What is 8 into 1? 8 plus 7, 15. Odd. Now take q as 2. 8 into 2, 16. 16 plus 7, 23. Odd. Take q as 3. 8 3s are 24. 24 plus 7, 31. Odd. Whatever value you give for q, 8q plus 7 will always be odd. Take anything else. 6q plus 3. 6q plus 3. 6q plus 3. Q is 1. 6 1s are 6 plus 3, 9. Odd. Q is 2. 6 2s are 12 plus 3, 15. Odd. So these expressions always are even. These are always odd. Now, if you take these expressions, they are sometimes even. For some values of q, they're even. For other values of q, they're odd. So when you look at 3q plus 1, you cannot say it's even or odd. For some value of q, for some values of q, it is even. For some other values of q, it is odd. Because if you take 3q plus 1, when q is 1, 3 into 1, 3 plus 1, 4, even. When q is 2, 3 2s are 6 plus 1, 7, odd. So it's like a chameleon. These expressions are chameleons. Suddenly they'll change their color. You'll think it's even, but it's odd. You think it's odd, it's even. So you don't know. It depends on the value of q. But the first and second columns, the expressions in the first and second columns are even always or odd always. First column, the expressions are always even. Second column, the expressions are always odd. The third column, expressions may be even or odd depending on the value of q. So if you want to assume an even integer, you can take let 2q be the even integer, or 4q, 4q plus 2, 6q, 6q plus 2, 6q plus 4. All these you can assume. Okay, let the even integer be of the form 6q plus 4. Because it is even. Or you can say let the even integer be of the form 8q plus 2. If you want to assume an odd integer, you can say let the odd integer be of the form 6q plus 3 or 8q plus 1 or 8q plus 7, because they are definitely odd. If you want to assume an integer, simply an integer. Why everybody is seeing there? Anga, it's raining or something? Okay, so if you want to simply assume an integer, even or anything, you can take any of this here. If you take these, these are even, or if you want to simply assume an integer, you can take these. Simply integer, even or odd, anything. Simply integer, you can take these. You can take these also for integers. But if you're specific, if you want to consider an even integer, you must take one of these. You want to consider an odd integer, only this. These are integers. These are integers, maybe even or odd. Is that fine? Now it's time for the test. Is it fine, children? Online students, any questions?
No, ma'am.
Rakshita, okay, good. Arjun?
No, ma'am.
Florentina?
No doubts, ma'am.
Okay. Raja?
No, ma'am.
Raja also. Why online today?
Ma'am, actually, I must have come to offline, but I just forgot and joined in online. I'm so extremely sorry, ma'am. From next class onwards, I'll come online, offline, ma'am.
For you and Arjun, it's always at the center. Please don't take online classes.
Okay, ma'am.
Yeah. Prajit, understood? Any questions?
Yes, ma'am. Understood, ma'am. No questions.
Very good. Then, Prajit, have you finished your annual exams at school?
No, ma'am.
Okay. When is the last exam?
27th, ma'am.
Okay. Danya, any questions?
No doubts, ma'am.
Okay. Danya, you are in Trichy?
No, ma'am, not in Trichy. I shifted to Chennai.
Okay, okay, fine, fine. Okay, good luck, darling. Update about your new school, okay? Let me know on WhatsApp.
Yes, ma'am.
Yeah, yeah, okay. Tanishka, any questions?
No, ma'am, it's clear.
Okay, darling, fine. So it's time for the test. All of you pull out your long rule sheets. Yeah, on offline student, I'm giving you the paper because விதவிதமா paper கொண்டு வரீங்க. அது கிழிக்கிறது பார்க்கணும். Leave the extra copy here, okay? Pass. Fast, fast. If you want extra sheets, you can ask me. No, no, leave the extra sheets here. Take one, leave it on the table. Okay. Oh, yours. No, no, no. I thought you. All right. Time for the test. Yeah, this is FA3. No, FA3, right? No, no, we have to take 3 and 4. Thursday, I did not give you the test. So this is FA3, children. FA3, formative assessment 3. Just write FA3. Yeah. Yes, get started. 5 minutes for this. Find the HCF of 506 and 1155 and express it as a linear combination in X and Y. Express it meaning express the HCF. It meaning express the HCF. Yeah, take down the question. Work this. Now it's 8:52. I gave this at 8:52. 9 o'clock, we'll go to the next question. You have 8 minutes. The same thing? No problem. Do. Done? Have we done this? This question in the class? Sure. Check பண்ணுங்க. No, yeah, this is second. Done, online students, 1 and 2. Online students, finished 1 and 2?
No,
Doing.
ma'am. 2, ma'am.
Okay, so that is FA3, okay? Question number 1 and 2 is of FA3. Just check if we have done this. The length, breadth, and height of a room. You don't remember doing. Okay, fine. Yeah, this is the FA4 children. FA4 first question. Yeah, yeah, continue. If you want an extra sheet, I can give you. Right, FA4, question number 1. FA4, question number 1. Please. Online students, please share the pictures of FA3, answers 1 and 2. Yeah, very good, Prajit. Second one, huh? Sorry. For question number, okay, this one, huh? You've got it in? Leave it. Is it more than 100? Okay, then leave it. Yes, very good, Rakshita. Rakshita and Prajit have shared their pictures. Tanishka and Tanishka.
Ma'am,
Yes, Raja.
ma'am, I just left the meeting for a while, ma'am. My as I told on Friday itself, my battery is making some sort of problem. So
Okay. Yes, children, have you taken down this question? FA4 first one. Have you written the question? All of you here? Online students, have you taken down this question?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. This is FA4 question number 2. That's it. End of test. FA4 question number 2. Online students, if you have completed FA4 question number 1 and 2, you may submit, you may share the pictures on WhatsApp and leave the call.
Can I send the photos later?
Okay, fine. Later meaning when?
I'm like 5 minutes later.
Yeah, okay, fine.
Can I leave the meeting now?
Oh, yeah, fine. Thank you, Prajit. Thank you, Prajit. Good night. Yeah. Okay. Yeah, it's time, children.
Ma'am, I completed. Can I leave, ma'am?
Yes, Tanishka. Thank you. Good night.
Thank you.
Ma'am,
Yes, Florentina.
I'm not having a phone right now. Can I send sometime later when I completed?
Okay, fine. All right. Okay, Florentina. Thank you. Good night.
Thank you, ma'am.
Yeah. Yes, children, it's time. Yeah, yes. FA3 first and then FA4. So, yeah, you can be. Thank you. Yes. Sashank, your dad's waiting. Okay. Raghavi, your mother's come. Are you doing the last one, Raghavi? Raja, Rakshita, and Arjun, have you taken down the second question of FA4?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes.
All right. So children, please complete it and share your pictures. I'll end the meeting now. All right.
Yes, ma'am.
Yeah. All right, children. Thank you. Online students, thank you. Good night. You may
Thank
leave the call. Please
night,
complete
ma'am.
the test and share the pictures.
Yes, ma'am.
Yes, ma'am. Thank you, ma'am.
Yeah. Yeah. Okay. Good night.